In the previous tutorial, in the previous part of object-oriented programming, we discussed how you can encapsulate properties and behavior, or you can say data members and function, in a single object, and then you can just use that object to assign data to it. But someone will ask a question like, what is the need to encapsulate function and data in a single object? So here comes OOPS concept, object oriented programming concept. So there are 5 features that OOPS concept provides C++ and makes code more efficient than procedural programming. So these 5 are, the number 1 is data abstraction. So the number 1 is the data abstraction. I'm just going to write all the 5 concepts first, and then I will explain them briefly. Next one is encapsulation. Number 3 is modularity. Number 4 is inheritance. And number 5 is polymorphism. So these are the 5 concepts that comes under OOPS concept. So I will explain all of them one by one, and in the subsequent chapters, in the upcoming tutorials, you will just see how exactly all of them are implemented, and most of them will be implemented in the tutorial classes and objects. So before that, we'll just learn about these concepts, and then we will see how these concepts are applied programmatically. So the first one is data abstraction. So data abstraction means hiding unnecessary information. So what does that mean? Let's take our previous example of car. So we know that our car will move if we will just do some operations, like if we will press the race pad, then it will move. So we know how to move a car, but we are not concerned with the inside concepts, like we do not want to know how the engine works. So we do not need to know unnecessary details. So these details are hidden, and these details are hidden, so these are known as abstraction of the data. So let's take another example of our switchboard. We know that there are switches in our switchboard. So what you are concerned with, that if you will press a switch, it will just turn on a light, and we're not concerned with what is going on behind the switchboard. We're not concerned with the connections. We're just concerned with which switch will just turn on the lights or turn on the fan. So this hiding of unnecessary information is known as data abstraction. And how is it implemented in OOPS concept? We know that in OOPS concept there are objects which have properties as well as behavior. properties are the data members and behavior are the member functions. So since in behavior we will implement the functions, we will just call the function. Let's say there is an object car and we want to move a car, so we will just call the function move using the object, and we will see here how we will do that in the upcoming tutorial. But the main important part is that we are just calling the function and we are not concerned with how that function is implemented in the class. We will just call the function and the function will implement it on its own. So an object will just hide the unnecessary details of that function. So this is known as data abstraction. The next one is encapsulation. So encapsulation means just combining properties and behavior in a single object. Properties plus behavior, or you can say data members plus member function. So encapsulation, you know that there is a class car, it has some properties and it has some functions, also known as behavior. So we know that it has properties and behavior, and now when we will create the objects of this class, object 1 comma object 2 and so on, so these objects, we can use these objects to implement the behavior as well as use these properties. So these objects encapsulate properties and behavior. So this is known as encapsulation. And one important concept here is that encapsulation is implemented using data abstraction. Let's see how. So we know that encapsulation is encapsulating the properties and behavior of the object. So there can be multiple objects. Let's suppose this is object 1. There can be another object 2 also. So when we are encapsulating the properties and the behavior, when we are encapsulating the properties and behavior in an object, we are hiding the data, or you can say the implementation, from the other objects. So this is known as data abstraction. So encapsulation has implemented data abstraction. So this is the how we can implement data abstraction, and this combining of properties and behavior under the same object is known as encapsulation. And in the tutorial classes and objects, we will create objects of a class just like this, and we will also see how we will assign the properties and behavior to this object. So let's move on to the third concept. Third concept is modularity. So in modularity, we can see that in object-oriented programming, we are converting our whole program into some modules. And modules are just a part of a program that can run independently. And all these modules will just combine, and they will provide, they all will combine and they will run the whole program. So using classes and objects, we are just dividing our program into modules. You can see that there are different objects. So these are the different modules. So this concept is simple. It is just, we can say, a feature of OOP concept. Feature of OOP concept. The next one that we're going to discuss is inheritance, and we also have a separate tutorial for inheritance also. In that tutorial we will learn how to implement inheritance. Here we will just define what exactly inheritance is, and we will just discuss about the concept of inheritance and why it and how it provides features to the object oriented programming. So you can see that if there is a parent there and the parent has a child, so we know that the properties and behavior, so the parent has some properties and some behavior also. So this is just a real life concept to represent inheritance. So there is a parent which has some properties and some behavior, which will be data members and data functions. So we will create a class parent for that. So inheritance is used when we want to create another class child which will inherit some of the properties of the parents. So that means that if the parent has some properties, we are not going to inherit all the properties, we will just inherit some of the properties and also some of the behavior from the parent. As we all know that the child has some properties and some behavior of the parent, so this real life concept is implemented in OOPS concept. So object oriented programming is used to provide inheritance, and you can see that this also reduces a lot of complexities, and it will also reduce our program, because if we have implemented a parent class, we do not again need to write all the same properties of the parent and child in the class child. We will just inherit the properties from the parent. So inheritance provides an efficient way to inherit the properties, and it also makes our program compact. So inheritance, this child class is also known as subclass of parent. So actually we can create a parent and a subclass of the parent which will inherit, or we can say derive, capabilities or you can say the properties from another class. And here we are just defining inheritance. We are not going to implement here, but we have a separate tutorial where we have implemented inheritance. So we will see this object oriented programming later on. So in inheritance, this is known as the parent class or the base class, and if you are deriving some capabilities or the properties from this class, then this class will be known as subclass. The next thing we will discuss is polymorphism. So before moving on to the concept of polymorphism, I want to give you an example of inheritance, or you can say a flow diagram here. So let's take an example of automobiles, or we can say vehicles, and this is an example of automobiles. So we know that in automobiles, cars are covered, then buses, then motorcycles, etc. So in this case, this is an example of inheritance, So we know that all these vehicles have functions that are common, and these are that all of them are moving. They all are moving objects, so they all will move. And these are all, you can say, subclasses of automobiles. So you can say these are the subclasses of automobiles, and you can say that this is a superclass or parent class or base class. So these are the subclasses. So you can see here that the functions that are defined in the automobiles, we do not need to redefine them in these subclasses, because we have inherited these behavior, or you can say these functions, from automobiles. So this is the only thing that makes our program compact, because you will just create a parent class, you will include the functions and the data members, and the next thing you will do is you will just create a subclass and you will just inherit those behavior, and you can just use them here with some other data. We will see that how we will implement in inheritance in the upcoming tutorials, but the main reason why we are discussing OOPS concept is that it will be used in a lot of places, not only in C++. We will also use OOPS concept in Java. So there are further a lot of programming languages where we will discuss OOPS concept. So because object-oriented programming is a very powerful programming, because it is providing a lot of features. It is providing some security features by hiding unnecessary information. It is making our program more compact by using inheritance, so that we are not redefining the functions that are already in the parent class. So it will make our program more compact. So in this tutorial we're not going in the in-depth details of how we will implement these concepts, these 5 concepts. We are just going to learn what are the meaning of these terms, and we will discuss them in the upcoming tutorials. So let's move on to the polymorphism. So polymorphism means that you will use a single name, or you can say you will use the same data, and you can process that data to be processed differently. So you will use some modifications on this data and you will process that. So let me give you an example of polymorphism. So let's say that there are some shapes in geometry, and every shape in geometry will have some area. So what we will do is, this is a shape class which will define how to calculate area. But for different shapes you need different formulas to process area. That means that you are processing data differently, because you are using different formulas to process them. So let's say I want to calculate the area of a rectangle. So to calculate the area of rectangle, I will need length and breadth. So I will need length and breadth, and I will multiply length and breadth, and I will get the area of the rectangle. So you can see here that in the shape area, we have parameters length and breadth for a specific shape. But for some other shape, let's say square, you will use the same function, but you only need just one side of the square, and you will just use a square to find the area of this shape. Similarly, you can find area of triangle and etc. So basically, polymorphism is to process data differently. And you can see here that all the functions have the same name but different number of parameters. So this is known as function overloading, which we will discuss in the next tutorial. Function overloading. So function overloading is an implementation of polymorphism. So it is an implementation of polymorphism, and function overloading is simple. It's just we are using the same function but with different parameters, and this is what the basic meaning of polymorphism is. We are processing data differently by using same name. So there is one more example that needs to be covered here. So let's take an example of the plus operator. So we know that when we use plus operator with two variables, it will give the sum of the variables. Let's suppose 1 plus 2 will give us 3. So this plus operator in this case is used to give the sum of the two variables. But what will happen if I will use A and B? So what will be the output? Output will give AB. So in this case, this operator is not used for adding A and B. It is used for combining them. So this plus operator is the same name. You can say that it has the same name, but it is processing our data differently. So this is how polymorphism works. So since you are using the same operator for processing different, you can say processing data differently, this is known as operator overloading. And overloading just means that you are using different operations, or you can say different process to process the data. So this is known as operator overloading. So this tutorial is about OOPS concept and how object-oriented programming is more powerful than the procedural programming. So we have discussed data abstraction, encapsulation, modularity, inheritance, polymorphism. We have just covered the basic details. In the upcoming tutorials, classes and objects, and function overloading and inheritance, we will implement this object-oriented programming using our C++ programming language.